Everyone's awake. My name's Neil Peterson. I'm a premier field engineer with Microsoft. Today we're going to be talking about complex maintenance with Configuration Manager and Orchestrator. And in fact, we'll see other components of the System Center 2012 SP1 product suite here as well. The objectives, takeaways, what I hope you get out of this discussion is a feeling that performing maintenance on complex configurations of computers, such as clusters, doesn't have to be a tedious, inefficient, or complicated task. I know prior to coming to Microsoft just about 3 years ago, I used to have to apply software updates with Configuration Manager to a 2-node SQL cluster on the weekend, and it took hours because we determined at the time that it was just too many moving parts. It was too complex to automate, so I got to sit down and do it manually. And even though it was a small 2-node cluster, it still took me several hours on a Saturday afternoon. That was no fun. So I'm here to show you it doesn't have to be painful like that. I'd like to position Configuration Manager and Orchestrator and really System Center as an ideal solution for performing this complex maintenance. And additionally, I'll be providing you with an end-to-end example solution. So we're actually going to patch some clusters right here, right now. At the end of the session, I'll show you where you can download the runbooks, the Orchestrator runbooks that we'll be seeing. I'll have those uploaded by the end of the week. Again, very important. It's just a sample solution. Every environment's different. But it should aid you on your way to patching clusters with Orchestrator if that's your desire. So the agenda, how we're going to get to those points is, first we're going to talk about cluster maintenance. What is it? Why are we here? Why does it matter? Why is it such a pain to patch clusters? We'll then look at the sample solution. We'll look at it kind of quickly, and then we'll dive deep into some of the pieces of it. Finally, I'll talk about the challenges and extensions you could build on top of Orchestrator, or how you could take this sample solution and fit it into your environment. And really, I should have titled this Deep Dive. We'll look at some of the challenges I had building this Orchestrator runbook solution and kind of how to get around those. So let's start off by talking about patching clusters. So traditional manual maintenance. I mean, if you were to just sit down at a terminal and have to patch a cluster manually, what are some of the activities that you're going to do? What are you going to do to get software updates on this grouping of computers, this cluster, and get them into a maintained state? First thing you're going to need to do is determine the cluster state. You need to know, if this is a 3-node cluster, you need to know what those nodes are. Clusters fluctuate. If we add a node next quarter, you need to know that we now have a 4-node cluster. So you're going to have to inventory that cluster and know about all the computers that are involved in that cluster so that you're maintaining all of them. Secondly, you're going to log into that first node, remove it from the cluster, pause it, drain any roles that are on it. You don't want to reboot this node while it's performing a workload. If that node's being monitored by Operations Manager, you're going to want to put it in maintenance mode. You don't want to fire off alerts that a machine's being rebooted. So, you're going to now have to manually open the Operations Manager console and put this box into maintenance mode. You're going to log into the node. You're going to launch Windows updates or whatever other update method you're using. You're going to manually trigger this process on that box. You're going to start the update process. You're going to wait for the updates to complete. That can take a long time. I'll pause here to recognize this is a busy slide. That's intentional. It's a busy process. You're going to reboot that node. Wait for the node to come back up. Validate the updates have been applied correctly. Validate that the cluster services have started. You don't want to try to add this node back to the cluster before the services have started. You're going to resume the node, add it back to the cluster. Remove it from Operations Manager maintenance mode. Repeat for each cluster node. If this is a large cluster, 16, 32 nodes, this could be a crazy process. No fun at all. And finally, you want to rebalance those services across your cluster. So quite a few steps there. What a pain that would be to perform manually every weekend across many different clusters. So there are some traditional methods for performing this maintenance. We just talked about the manual execution. That's what I was doing 3 years ago. Like I said, to a 2-node cluster. Even that was no fun. I've worked with many individuals who have set up complex configurations of Configuration Manager collections and maintenance windows. So you can kind of create a hierarchy of collections with different maintenance windows, drop different nodes and different collections, and kind of stage the application of updates and reboots based on those maintenance windows and different collections. While, yes, I'm sure it worked, doesn't sound very fun or effective to me now. Complex configurations of scripts, scheduled tasks, and alternate voodoo. I mean, I've seen some pretty slick stuff out there using PowerShell, using scripts, using kind of homegrown solutions to perform this complex maintenance. And no doubt, some of it's great stuff. I mean, I'm sure there's some really awesome stuff out there. But, it becomes, is it portable? Can you take some of those solutions and pick them up from one environment, drop it into another environment? Or, there's that cliched notion that what happens if the individual that wrote the scripts got hit by a bus? Could you continue to maintain those clusters based on that, complex yet awesome solution? So, again, just a traditional method I've observed that's probably pretty cool, but there may be better solutions at this point. And this fourth one is the one that I see most often and probably the scariest out of all of them. So a little background on what I do as a transactional Premier Field Engineer. I visit lots of customers. I may be with a new customer every week. And it's this fourth one that I see most often. And that is that in many cases, complex systems are just excluded from the maintenance process altogether. That system, that cluster is just way too important for us to risk having to do maintenance on. That makes absolutely no sense whatsoever. But I see it. Believe it. I see it. We don't know what to do with it, so we're just not going to do anything. We don't know how to reboot it. We don't want to sit down. We don't know how to, orchestrate the process of putting updates on this clustered set of boxes in an efficient manner. So let's just not do anything with them. If you think about the systems we're running on clusters, you've got banking systems, medical systems, pretty critical systems. That's why they're on clusters. We want to ensure high availability here. To not maintain these systems is just crazy. But there's good news. It's the modern age. We now have several different options for gracefully applying software updates to clustered systems. To name a few, the first being Windows 2012 Cluster Aware Updating. So if you're not familiar with it, and this is something I've just learned about recently, Windows 2012 failover clusters come with a built-in cluster patching mechanism, Cluster Aware Updating. The second one, System Center 2012 SP1 Virtual Machine Manager. Virtual Machine Manager has the capability to apply updates to the clusters that it's hosting in a graceful fashion. System Center 2012 SP1, Orchestrator automation. That's what we're here to talk about today. That's what I'll be showing you. And there's potentially others, but these are the kind of the top three, Windows and System Center solutions that I see kind of in this modern age of maintaining clustered systems. So before we get talking about the System Center 2012 SP1 solution or the sample solution that I'm going to show you, I did want to just take a moment to talk about 2012 Cluster Aware Updating. The solution I'm going to show you is pretty slick, but in a lot of circumstances, this might be a better fit. So I wanted to just make note of it here. So 2012 clusterware updating, basically you have one-click clusterware updates right from within the 2012 failover cluster console. It integrates with WSUS. Configuration manager is not needed. We'll talk about all the components of the solution I'm going to show you, and one of those is configuration manager. Here it is not needed. It can be automated, extended with included PowerShell commandlets. However, Windows 2012 is required. So this solution works on Windows 2012 failover clusters. My bet is on that there's a lot of Windows 2008 clusters in existence today. I know I work on them quite often. Therefore, I've got a solution for you. We'll look at it right now. But like I said, I just wanted to just make mention of this because it's a slick solution and would be the perfect fit in many, many circumstances. So patching clusters with System Center 2012 SP1. So I'm about to show you a solution, and we're going to go through it from start to finish. What are the components of this solution? Well, we've got a failover cluster, Windows 2012 failover cluster. I've gone through the same scenario with just a variation of the same runbooks I'm going to show you on Windows 2008 failover clusters. In fact, I started developing this on Windows 2008 failover clusters. So it works there as well. System Center 2012 Orchestrator SP1. This should work in non-SP1 as well. System Center 2012 Configuration Manager SP1. The solution I'm about to show you does require System Center Configuration Manager SP1. I am using some of the PowerShell commandlets that shipped with SP1. System Center 2012 SP1 integration packs pulled into Orchestrator. And System Center SP1 Service Manager, little typo there. Optional, I will be demonstrating this solution using Service Manager. And then Operations Manager, I've got the nodes of my cluster being monitored by Operations Manager. Obviously, that's not a requirement of patching clusters, just to give you a layout of the technologies that we'll be seeing. They're all there. I'll pause here and take a moment to note that we're going to be looking at some Orchestrator runbooks pretty heavily. If you're not familiar with Orchestrator, I'm not going to go into kind of the cosmetics of building runbooks. So there's a certain level of Orchestrator knowledge that's going to help you as we go through these demos. Definitely, I will try to make note of kind of best practices and what's going on if you have no experience with Orchestrator. But if you see what you like, there should be other sessions this week on the basics of Orchestrator, and there's a ton of good work out on the internet. Definitely look up Charles Joy's blogs, where he will walk through the basics of building runbooks and design practices, etc. I'm not going to go through some of those basics during this demonstration. There's just not enough time. So, okay, so where are we at? We know clusters are complex to patch. We know that there are traditional methods that work okay. We know that we're about to see a System Center 2012 solution. So what does this solution do? So what's different between this and those other solutions? Well, the first thing it's going to do is an update is requested through Service Manager. So I've got a Service Manager catalog. We're just going to go out to that catalog and say, hey, I want to update this cluster. We're going to prepare the Configuration Manager environment. We're going to create collections, create a software update deployment targeted at that collection. We're going to examine the cluster, just determine the nodes, dynamically determine, what are the nodes that make up this cluster. Put the first node in Operations Manager maintenance mode. Pause the node. Drain all the roles off of the node. Add the node to the Configuration Manager collection. Refresh the Configuration Manager policy on the machine. Apply the updates. Examine that node to determine when the updates process has completed and determine if a reboot is required. If a reboot is required, do it. Rejoin that node back to the cluster. Remove it from Operations Manager maintenance mode. Repeat these steps for each node in the cluster. Update the service request. Close it. Clean up the configuration manager environment. This is not a lot different than the steps that we kind of saw when manually patching a cluster. The big difference is the update administrator is playing golf or skydiving or whatever they like to do on their time off. It's all automated and triggered through the System Center 2012 product suite. So let's jump into a demo. All right. So I'm going to quickly, it's going to be a pretty long demo. In fact, this session's almost all demo. What I'm going to do is kind of go over this at a high level. We're actually, like I said, we're going to patch clusters here. In fact, we're going to patch a 2-node Hyper-V cluster that's running 20 virtual machines in that cluster environment. If I was to just hit go, it'd be a long demo with some uncomfortable silence as we watched it patch. So what I'm going to do is run through it at a very kind of high level, kick it off, walk through kind of one of the cycles, like watch it patch one of the nodes, and I'll be flipping back and forth between configuration manager and operations manager and service manager. We wouldn't have to do all this stuff in real life. Like I said, we would be playing golf. But to demonstrate it, I'm going to walk through all of that for kind of one iteration of it. Then I'm going to jump back into some slides, and then we'll come back and kind of see the completion. But to just sit through the whole thing would be kind of a waste of our time. To kind of lay out the environment, I've got a 2-node cluster here. As you can see, I've got 20 VMs running on this cluster. So 20 roles. And you can see these are balanced between node 1 and 2. Kind of this column right here, owner node. If you look at the last digit, we've got a 2. And we've got some 1s. So I've got 10 nodes on each, 10 VMs on each node of the cluster. Got configuration manager, operations manager. We can see here both nodes are healthy and neither nodes are in maintenance mode. All right. Orchestrator and service manager. Before getting started, I want to talk about a couple of the prerequisites that need to be in place in configuration manager in order for the sample solution as it is right now to work. And again, these runbooks will be available for download. And it's very simple. Really, we need to have a software update group defined. So I've got a software update group that contains 4 updates. Obviously, in a production environment, we'd have a whole month's worth, a whole quarter's worth, a whole year's worth, or whatever. But to keep the demo shorter, I've only put 4 updates in there. And then we also need to have a template defined within Configuration Manager. So these are activities that generally, a patching administrator would be taking care of for the whole environment. And then in this case, the cluster administrator may just be piggybacking off that work. But what we'll be seeing is that in the Orchestrator runbooks, when we go to deploy updates, we're going to reference this update group and this template. In other words, the automation that I've put together doesn't create the deployment, it doesn't create the template. Those have to be in place before we can do this. With those in place, let's take a look at the runbooks. And again, I'm going to go over it at a very high level. We'll kick it off, watch it run, and then break back into some slides. So if you were to go download these runbook samples, I've piped in a couple variables. We've got the FQDN of the environment, a password, site server, the update group, and the update template. So we just talked about those as being prerequisites. Basically, we just need to drop the name in these variables of the update group and the update template, and then a username. This username and password is going to be credentials that we're going to use to execute some PowerShell against the Configuration Manager site server. And the FQDN is used when putting the nodes into Operations Manager maintenance mode. So these variables, this is the only configuration that needs to be done. Import the runbooks, configure these variables. So jumping into our runbooks. And here I will talk a little bit about design so that as we walk through these, some of the design choices I made here make sense. When I develop my Orchestrator runbooks, I attempt to keep them very small and kind of modularized. So right here we're looking at a runbook that basically starts maintenance mode in Operations Manager for a particular computer, and that's all it does. That's all this particular runbook does. One item. This is so that we can reuse this runbook now anywhere in any runbook solution. It may have nothing to do with which patching clusters. It may be something else, but now I've basically made a function that can be reused. So I tend to keep my runbooks very modularized. We could obviously just create one big, huge runbook that performs everything and just goes through the whole process, but then we're going to just have this gigantic runbook, fairly inefficient and somewhat spaghetti-like. So with that, though, I want to point out how I have my runbooks organized. As you can see, this solution contains quite a few runbooks. I generally, in a production environment, would not put these numbers here, because now you're kind of encapsulated. It kind of goes against what I just said. If I wanted to reuse this Operations Manager, maintenance mode runbook, it doesn't make any sense to call it 7.1 because it may be the second action that I take in a solution. I've done this just for the sake of ease of demonstration. So the organization here might not make a lot of sense in a production environment. I've just done it so that I can click through them rather easily. I would generally like have a modules folder and keep all my Operations Manager, maintenance mode, runbook stuffed in there and just refer to them whenever I need them and not necessarily kind of pigeonholing them into being specific to this solution. That's just for demonstration's sake. So let's walk through this. So I've got a main worker runbook that basically runs all the other runbooks when they need to be run. The first thing we're going to do, I'm going to come in and say, hey, I want to update this cluster. What's the first thing we need to do? We need to prepare the configuration manager environment. So from this main worker runbook, we execute the second runbook. Here we're going to create a collection. We're going to deploy software updates to that collection. So I talked about the prerequisite of having the group and the template. Those are specified right here. So we created them configuration manager, specified the name of those in the variable, and just referred to the variable right within this activity here. I then used some PowerShell to get the deployment ID of that of the deployment that we just created. We'll use that deployment ID later on to determine, hey, has the machine received the deployment? We'll want some way to know whether the machine has received the deployment over just kind of wait 5 minutes and assume it's there. Just a little housekeeping on the data. And then I'm going to return that deployment ID back up to the main worker runbook. So configuration manager is ready to go. It's ready to patch. At this point, we have a collection with software updates deployed to it, just as if we'd manually gone in the console, created the collection, and deployed software updates to it. Next thing we need to do is detect the cluster state, deploy the updates. So here I've got some PowerShell, and don't worry, we're gonna look at this PowerShell. First swipe overview, second swipe deep dive. I'm going to examine my cluster. So I've got the name of the cluster, but I have no idea at this point what nodes make up that cluster. I'm just going to bounce some PowerShell off the cluster, pull back those nodes. A little housekeeping on the data. We'll talk about this. And then for each node in that cluster, I'm going to run the next step, which is to start applying the updates. And this is really the big work that we're doing here. So I've got a node now. I've got the first node, and I want to do something to it. What's the first thing I'm going to do? Start Operations Manager maintenance mode. You'll notice here we're just calling another runbook. Modularly. Start maintenance mode. Come back. Second thing I'm going to do is suspend that cluster. Remove it from the cluster. Drain the roles from it. I'm just calling a piece of PowerShell. Suspend cluster node. Suspend cluster node dash cluster, the cluster name. Basically the same as coming in here, right-clicking on the node, pause, drain roles. That's all we're doing, just with PowerShell. Okay, so my node is in Operations Manager maintenance mode. It's been removed from the cluster. It has no services running on it. It's ready. We can reboot this thing at will. We're going to add it to the collection. Once it's in the collection, we're going to refresh the machine policy. Configuration Manager policy by default refreshes every 60 minutes. We don't want to wait 60 minutes. We know we're ready to go now, so we'll just reach out and tickle the machine. These two right here we're going to look at during the deep dive. I want to check that machine for policy. I want to make sure that it's received the policy that is those software updates. And I'm going to loop. You can see the little loop. Let me see if I can. I'm looping on this activity. I'm going to loop on that activity until that machine has received the policy that has those updates. And not just some other random, policy refresh. We want to make sure that it knows about these updates. And then I'm going to monitor the update installation. Every machine's going to, machines are going to take different times to install updates. We don't want to just, wait 5 minutes, then reboot. We need to watch the updates install and not do anything until they have completed installing. Then you can see we branch here. Believe it or not, some updates don't require reboots. So we want to determine if those updates require a reboot. And if it does, we're going to branch off, restart the system, wait for the system to go down, wait for the system to come back up. If it doesn't require a reboot, we're going to jump right back into resuming that node to the cluster and then removing it from Operations Manager maintenance mode. But you might say, but wait, we don't care if it needs a reboot or not. We're going to reboot it. Okay, well, we modify the runbook. That's the great thing about these things. It's plug and play, move it around as you need to. Just stick a reboot in there anyways. Once that's completed for the first node, we come back out, our next node goes in. Same process for every node in that cluster. So since we're using PowerShell to examine the cluster and pull back the nodes, we know if it's a 2-node cluster or a 64-node cluster. And we're going to perform the same process for each node in that cluster. So once the last node's completed, we come back out to 3. We're at the end of the runbook. We hop back out to the main worker runbook. Next in line is to clean up. All I have it doing is deleting the collection and configuration manager, which also deletes the deployment. So at this point, it's like we were never there. We're done. Once that's completed, come back out to the main worker runbook and update and close SR. And this is just some service manager maintenance. We're basically updating the service request. Hey, this has been completed. I did something kind of cheesy in this demo, and I put, like start time and end time. So right in the request, you can see when we started updating the cluster, when the end time was, so you can kind of get a good feel of how long it took to perform the request, and then we close out the request. And at that point, it's done. So full cycle. So let's get it started. So here we have the Service Manager portal. I've got the whole solution set up as a service request or a request offering. Configuration Manager requests. Deploy updates to failover cluster. So here's the point where I hope everything works. All right, so your request has been submitted. So if you think about it, this is great. Wow, I'm about to patch clusters. All I did was enter a name and hit go. SR 191. So we'll hop over into Service Manager. And my Service Manager environment's a little bit slow. So here it is. SR 199, notice my description is empty. I've got two activities in here, basically the runbook activity, and then I've got a manual activity. Basically, if you just have the one runbook activity, it will execute the runbook and close the request. I put a manual activity in here to keep the service request open throughout the duration, and then in my runbook solution, one of those activities was to close the manual activity, which then closes the request. And that's running. And we can see that we've actually started the cluster patching process. So configuration manager is rocking. In fact, it's finished. This all happens pretty quick. I'm going to be jumping around quite a bit. So here we can see, here's our collection. I just set it up to name the collection the same as the cluster name. If I look at the properties of this collection, we can see the 4 updates in my update group are deployed to the collection. No strings, no mirrors. I didn't do anything there. Back in Orchestrator, we've actually detected the cluster state, and we are now applying updates, or in the process applying updates to one of the nodes. So if I click in Operations Manager, you can see right here that CLX1 is in maintenance mode. That's the little wrench-looking thing right next to it. And we're actually, you can see here that the node has been paused. And if we were quick enough, we can see that we've got, there's a couple more. So we're live migrating all of the virtual machines off of node 1 onto node 2. And we've got a couple still running there. And bam. So what we have now is 20 virtual machines being hosted off of node 2, and node 1 is in a completely paused state. So we can perform maintenance on it. So in fact, if it was the core host, in fact, I think it was the core host, and we just missed it. So everything was migrated over to node 2. The VM's running on it, core host, if any of the storage was being hosted on 1, it was moved over as well. So if we bounce back over into Orchestrator, you can see where we're at. And again, you wouldn't do this. Checking for policy. So we're now looping on that bad boy, waiting for policy to arrive. And we'll give it a couple seconds here. And I keep jumping back to node 1. We'll actually watch the updates start to install and then move on from that point. I'm glad you brought that up. So, because of the nature of this demo, I haven't put a whole lot of error control in here. But yeah, in a production environment, for every action, I would check and make sure that a collection doesn't exist in that case. In fact, if we have a couple minutes afterwards, I can show you what I would do with a real running runbook. And it would be something like, check for collection. If collection exists, add machine to collection. If collection doesn't exist, create the collection. So for the sake of having this a little more concise for demo purposes, I've left most error control out of this, but you would want to add that type of error control in, which would dramatically increase the amount of activities that were on the runbook designer, making it a little more difficult to demonstrate with. But definitely an extremely good point there. In fact, we missed it, so our cluster node just went down. So the updates were applied to it. We restarted the system, waiting for it to go down. I know that looks bad. It looks like an error just happened, but that's actually how I have my runbook set up. I'm actually pinging the system until it goes down, at which time an error occurs, and then I move on. That's how I know that my system has gone down. So node 1 has been patched. I'm actually going to jump into node 2. And we can see that the box is back up. So node 1 is back online, however, still paused. So we're actually resuming that cluster node now. So adding it back to the cluster. So pretty soon that pause should return to up. And I'll give it a couple seconds to do that, and then we'll jump back into the slides and then take another look at this at a deeper level. So the node is back up, and you can see that we are failing those roles back over. So inside the PowerShell, you can specify whether to fail the roles back over or not. And just for demonstration's sake, what we're really doing there is I've specified a preferred owner for each virtual machine, and we're just basically failing. We've brought one back online, and we're failing all of the nodes that prefer it as an owner back to that host or to that node of the cluster. So I'm going to step back and let this continue to run. So at this point, we're basically the process. It's going to do the same thing for node 2. It's going to pause node 2, take all the VMs off of node 2, put them on 1, patch 2, and then spread the VMs back out. So there were, really, that's a pretty complex process, but really a lot of that runbook automation was pretty simple. It really was just kind of piecing stuff together. However, there were a couple items that were a little trickier, and I'm going to dive into those right now and just talk about what I did to get over some of the hurdles. So what were the items? And a lot of these are going to be useful not just in this runbook solution, but all runbook solutions. There's just some tricks and tips to designing runbook solutions, and some of these are kind of general in nature. So first off, there is no native cluster integration pack. So we don't have a failover cluster integration pack. So some basics of Orchestrator. If you're not familiar, a lot of the activities that I had pulled out onto the designer come from what we call integration packs, like the create collection activity. I pulled that out and put in some data. It knows what to do. It's got the code. It knows how to create the collection, or the operations manager one to put the machine in maintenance mode. I just dragged that out there and filled in some data. Well, there is nothing for failover clusters that I can just drag out and fill in some data, and it takes care of putting the node and pausing the node and removing the roles from it. So they're just, an integration pack doesn't exist, at least at the time I put this slide deck together. That's okay, though. There's a generic Orchestrator activity called run.NET script, and it does just that. It runs .NET scripts or even C# code, etc. So I was able to leverage native failover cluster PowerShell commandlets to do what I needed to do, which was gather the list of nodes, pause the node, drain the nodes. However, it thickened. If you're not aware, the run.NET script environment that Orchestrator invokes with PowerShell is a 32-bit environment. However, the 2012 failover cluster commandlets are 64-bit. So natively, there was a little bit of trickery that we have to do to run 64-bit commandlets from the Orchestrator run.NET script activity. I'll show you what I did. Second, and this one is totally true for most runbook solutions that you're going to encounter, is multi-value data. And I'll talk about what multi-value data is and how I got around it. And I can see the demo, so my second node just rebooted. And then these last two were kind of the most tricky here, and they are specific to Configuration Manager. One was detecting when the Configuration Manager policy had arrived. Not only detecting when Configuration Manager policy had arrived, but when it was the right policy. You could get into a situation where you coincidentally received Configuration Manager policy. However, your updates deployment hadn't been processed yet, so they're not included in that policy. So we had to make sure it was the right policy. And then finally, determining whether a reboot is required or not. So for all four of these, that's kind of the deep dive. I'm going to deep dive in all four of these. So first is the PowerShell script. 32 versus 64, and then also using the failover cluster PowerShell within the run.net script activity. So if you look at the PowerShell on the screen, and we'll look at this again in the runbook activity, what I'm doing there is setting a variable, all nodes, equals to, and then I've got this weird string that ends in PowerShell.exe. What I'm doing here is invoking a second PowerShell session, a 64-bit PowerShell session. So just to repeat myself here, Orchestrator, run.net script, PowerShell sessions are invoked in a 32-bit environment. So I'm kind of tricking it into enumerating another session that's 64-bit, and then I'm running my 64-bit commandlet, which is get cluster node dash cluster and the cluster name. So this is kind of two issues in one. First issue being that there was no native failover cluster integration pack. Well, that's okay. We've got PowerShell. And secondly was the 32-bit versus 64-bit environment. So we'll look at that again in the Runbook Designer. So second one, multi-value data handling. So has anybody in the room have a couple, bigger runbook solutions under your belt? Anybody triggered a runbook and go, oh my God, why did I just send myself 19 emails? Or why did I just do something 19 times when I only wanted it to happen one time? So the way the flow of an Orchestrator runbook happens is first object happens, second object happens, third object happens. If that third object happens to enumerate 3 more objects, the next object happens 3 times. So it's this theory of multi-value data handling. And I'll show you an example which should solidify the theory. But it's a problem. Not a problem. There's a learning curve to it in most runbook design. So in this case, I'm running a PowerShell commandlet get cluster node. Well, if this is a 3-node cluster, we've now enumerated 3 pieces of data. So the next activity happens 3 times. So sometimes you have to do some creative either data manipulation, or in this case, I take my 3 nodes, and then one at a time, they trigger this apply updates runbook. So I'm actually triggering another runbook. Well, if you notice here on the right, I don't have zoom it on this machine. Over on the right-hand side, there's a little checkbox wait for completion. So what happens is the first node goes in there. I've got 3 pieces of data ready to be passed to that next activity, which happens to be a runbook activity. Well, the first one runs, we wait for it to complete. Then the second one runs, and we wait for it to complete. Then the third one runs, and we wait for it to complete. So not a big deal. In fact, the more I work with runbooks, the easier multi-value data is to handle, again, either through data manipulation or encapsulating that multi-value data into its own runbook and then triggering a sub-runbook one at a time. And I'll show you this again in the Runbook Designer. Third one, confirming the proper policy has been applied. So when we did that first swipe, or when I talked about the pieces of technology used in this demonstration, I talked about PowerShell commandlet for Configuration Manager, where I pulled the deployment ID and kind of stuffed that away to use it later. And then we looked at, we saw in the Runbook Designer, which we'll look at again, where I was kind of waiting for that policy to apply. All I'm doing is WMI query on the CCM, Software Updates Deployment Agent namespace. Basically, select star from CCM target update EX1, where ref assignment like deployment ID. So we can actually, in WMI, find the very specific, we can see that the deployment has been applied to the machine. At that point, we know we're good to go. We can move on. In fact, when we're done here, I can show you, it actually, in my environment, loops a couple times until that policy has been applied, and then we move on to the next step, which is to watch the deployments roll. and the fourth challenge I want to talk about. So once policy has been applied, how do I determine that the machine is finished installing updates? You could just put a reboot at the end of the updates, but I want to know what's going on. I want to control it. So I did some looking in the SDK, and there's actually an article. Well, let's start off. There's a namespace, a WMI namespace. Again, we're going to be querying WMI, CCM client SDK. And there's a query, select evaluation state from CCM software update. And there's in the SDK, there's a list of what all the evaluation states mean. And that's probably pretty small up there, and I do apologize. I don't have zoom in on this machine. But again, we'll jump into the console. But basically, I can pull back the value of evaluation state and then take action based on it. So some examples of what evaluation state may be, and you're used to these from reports if you've been doing any kind of software updates, is waiting for content, installing content, reboot required, etc. So we know kind of what state the client is in versus the application of the updates. And I'll dig into these. So let's get back into the console. And what we'll do is first look at how we did. So because my last activity is really to kind of clean up Service Manager, I'm just going to check that activity. I can see it's completed. So I'll jump into Service Manager. Let's just take a look here. Yep. So cluster maintenance started, cluster maintenance completed. I've got the times that it's happened. So if I jump back in and just inspect my cluster real quick, the cluster's up. Notice there's no recent cluster events. So that whole process happened without erroring or throwing some sort of haywire event. We got through that whole process clean. Let's look at my nodes first. So both nodes are back up and running. And then because of the preferred node settings, we can see that, split down the middle, we've got 10 VMs back on each node. So effectively, we just totally, in an automated fashion, took 10 VMs, moved them to another host, patched that host, moved 20 VMs back to the other host, patched the first host, and then moved 10 nodes back. So that's done. That's cool. But I did want to deep dive into a couple of these more unique situations. So get cluster nodes. So here's an example of using the PowerShell, enumerating the 64-bit environment, and using native PowerShell to get the data we needed. So this is the same PowerShell we saw in the PowerPoint slide, but just to see in its native form. So again, because there's no failover cluster update integration pack, I'm using PowerShell. I've set this variable all nodes. This thing just beeped at me. Okay. I've set the variable all nodes to the results of get cluster node space dash cluster, and then the name cluster, which was input into the Service Manager service request. And then I'm publishing those nodes back out. All right. And then some multi-value data handling. So out of this activity, what I'm actually getting is a comma delimited string of every node. I can't do much with that. So in this case, it was node 1, comma node 2. That's what the PowerShell gives me. I can't do much with that. I can't pipe that into anything because it doesn't mean anything. It's two computer names with a comma between it. How can I act on that? So I've actually got another piece of PowerShell here, just trim data nodes, trim data get nodes, and I'm basically just taking that comma delimited string and breaking it up and stuffing it into an array. So now I started off with a single piece of data, but I've actually created my own multi-value data here. So I actually have a collection now, or an array of nodes in this cluster. And I'm publishing that data out as node. I then invoke a runbook taking in the node from the activity before it, which was called trim data get node. So you can see that the second line in my parameters. And then there's that wait for completion check mark. So I've created multi-value data. I've created a collection of nodes. And then the activity after that is going to run once for each node. But because I have this check mark wait for completion, it's going to run one at a time. So I'm going to patch one node at a time. So if you had a large cluster, there's actually things you could do here. If you had a large cluster and you wanted to patch 4 nodes at a time, 5 nodes at a time, this would be pretty easy within a couple pieces of PowerShell to, and also, let me point this out, through a couple pieces of PowerShell and then job concurrency, you could easily manipulate a solution like this to patch 4 or 5, however many nodes at one time. You would just need to work with the data and work with the job concurrency. And that may be desired with a large cluster. But in my sake, honestly, I found it just easier to patch one node at a time. All right, so we had PowerShell, data manipulation, or multi-value data. So the third thing was checking for policy. So I talked about the namespace and the WMI query that I could use. So here it's just a native activity. So when you install Orchestrator, you've got an activity, query WMI. All I'm doing is querying WMI for that deployment ID. So recall, earlier on, I created a collection, I deployed software updates, and then I ran some PowerShell to pull the deployment ID of those software updates. I then passed that deployment ID back to my main worker runbook. And then when I deploy, and then I am piping that into the actual deployment runbook. So here you can see the deployment ID, and then I'm referencing that in my check for policy WMI query. So every time you create a deployment ID, every time you create a software update deployment, it's going to have a unique ID. And here we're just kind of bringing that ID along with us through the chain of runbooks, at which time we can inspect the machine to make sure it's received that deployment. And then this one's pretty fun, and that is monitoring for the updates. So I talked about in the SDK, it lists out every state that you're going to find in evaluation state within the client SDK namespace. So here I am basically querying WMI for evaluation state. What I'm doing is looping on that query. So I'm looping every 5 seconds. And I exit that loop when I can see that the client is no longer installing updates. In other words, if the evaluation state is like downloading content or installing updates or waiting for content, I don't want to move on because we're not done yet. So I basically continually loop, pulling the value of evaluation state every time I loop and compare it against the data that I was able to pull from the SDK. So there's a little bit of manual work here. I had to come in and make all of this criteria, but it's solid. So for every value that is represented, or for every potential value in evaluation state, I've created an activity, and those activities are to move on or not. Additionally, I branch. So I may need to reboot here, I may not to. I can use the same data. because in evaluation state, it will indicate whether a reboot is required or not. So I've got two different branches here, properties, and basically if evaluation state is 8 or 9, a reboot is required, and I'm going to go that way. If it's anything else, a reboot is not required, and I'm going to go that way. In fact, if it's empty, a reboot is not required, and I'm going to go that way. So while we're here, just a little kind of out of scope, but isn't that pretty funny? Look at that. WMyQuery results as a string matches pattern, and then a little funny pattern. That actually is an empty result. So we queried evaluation state, and it came back empty, indicating no reboot is needed. It's just a little neat tidbit there. Cool. So we patched a Hyper-V failover cluster, dug into some of the kind of more problematic scenarios I ran into when doing so. I don't think I have very many slides left, but I'm going to hop back to the slides. So taking it further. So, I mean, this is the great thing about Orchestrator. I mean, it's pretty simple, and you can take one solution and adapt it for your environment. You can do some pretty dang cool stuff with this. So real-time reporting. So for every activity that happens, we could easily write to a database. Hey, collection was just created. Hey, node 1 added to the collection. Node 1 policy refresh. So we could, easily drop in SQL somewhere every action that we've taken. And then have another process pulling that SQL, reporting on that SQL. So in real time, you can watch your machines patch. Enhanced service manager integration. Taking all that data, instead of just having a start time and an end time, for every activity, write that to a database. And then when you're done, pull all that activity and throw it in the description of your service request. So you've got a complete record of that patching process. So you're playing golf, and this thing's taking notes for you. That's pretty cool. Email notification. So I do have some blogs out there with kind of older iterations of this solution. Some of those include email notifications. Some of those are enhanced email notifications. So same scenario, writing data to a SQL database. When I'm done, pull that data out, create an HTML formatted email that has a table that shows me every step of the way, what time it happened, what time did these servers go down, what time did they come back up. And then basically, to infinity and beyond, just be creative. You can do pretty much whatever you want to do with this stuff. That is my presentation. We've got about 16 minutes left. I can take some questions. Actually, let me bring up a couple more things. There's my blog, blogs.technet.com/Neil P. I've got tons of configuration manager and orchestrator related content up there. I mean, tons of it. Done some really cool stuff with software metering, software updates, automatic approval, etc. This is the address. Actually, if you go to this address right here, this gallery.technet.com, Microsoft.com, there is a runbook up there right now that is this pretty much the same runbook that we saw. I've made a couple modifications over the last week. I'll have those up there by the end of this week, but that's where it'll be. Some related content. A lot of it is past, but introduction to failover clustering, best practices for runbook authoring and managing Orchestrator, and then Configuration Manager 2012 and Orchestrator. So other things, totally related to the content that we just talked about. Please fill out your evaluation, and this will all be online soon. And I'll take some questions, and I'll also be at the speaker panel in about 15 minutes, I believe. Thanks a lot.